Hi guys, welcome to Learn Electronics Repair. I have an amplifier here, Power Amplifier InterM MA-930. This one is quite heavy, as these things always are. Okay, definitely some weight in that. The rating of this is 450 watts per channel into 4 ohms, 900 watts in bridge mode into 8 ohms. Okay, so it's roughly a 1 kilowatt amplifier. That would tell me from the weight of this and the rating, this is going to have a linear power supply, and this is going to be almost certainly a class G amplifier which has switchable voltage rails. So the plus and minus applied to the amplifier will switch between probably plus and minus 45 to 48, something like that, and plus and minus 90 to 96, something like that. So that's what I'm expecting to find. The customer says this is just dead. So I think rather than just plugging this in, let's have a look to see if we can see anything obvious first. So this is pretty much as I expected. Large pork pie transformer down there. Big smoothing capacitors, the bridge rectifiers, yeah, be down in here somewhere. Yeah, they actually bolted, I can see one of them there, okay. 2 amplifier modules. Are there any fuses? This is a good place to start. So yeah, there's a fuse on the back. This would be the first thing there. Well, the fuse is completely blasted, so that tells us there's a short circuit somewhere. I mean, there's no point changing this. Yeah, when it's like this, when it's vaporized rather than just the wire broken, that means there's been a massive surge of current, so that means there is a short. Hopefully we can find that quite easily. Let's have a look. Okay, so we can see the main socket is down here. So power comes in on these 2 wires, yeah, these 2. And this goes to the switch. So this is a dual pole switch. There's two wires coming in, 2 coming out, so there's 2 poles. The one's coming out, one goes to the fuse, and the other one goes to this end of the transformer. And then the other end of the transformer connects to this thing. Here. This is, well, it says all wires. So this is a relay, rather unusual with connections on the top and obviously connections to the board. So it goes to this relay, and then that comes back to the end of the transformer. So something has to switch this relay on. Do you know, I think this relay, the way it's wired up, I don't think this has to be switched on for this to work, because unless there's power, nothing can switch it on. This could be a circuit breaker, it wouldn't be surprised. So this opens maybe under some fault condition. That perhaps makes sense. If that's the case, and bear in mind guys, this is like subjective, yeah, it's just trying to work this out, but if that's the case, this will probably read short. I'll just get onto the terminals of it. Well, actually it reads open. Oh, that reads open, alright, that's interesting. So how does that switch on? These wires, these only go down to the switch, they don't go to anywhere else. I think I can easily just drop this front panel forwards, that might help me to get, oh, in fact, no, I don't even need to do that. This clips off, okay, so and clip this off here, I can hopefully get to the switch. Yeah, I can get down to the switch contacts. Right, let's see if we can just work this out. Yeah, I can't easily get onto these terminals, but it probably doesn't matter. So if I switch the switch to the on position, then I can just measure now from the power coming in. Put this where you can see it. So power coming in, with the switch on, one of these should come to this connection going into the transformer. I can get into here, I think, with these sharp probes. Okay, so let's see. So one of them goes to there, and the other one should go to the fuse holder. There. Yeah. It goes here. So that goes to the fuse holder, then from the fuse it goes to this relay thing here, and that comes to the other end of this transformer. So let's get this off here. Yeah. I don't think we'll have a connection here. No, that reads open. This is coming from the fuse to there. So this thing's reading open circuit. Now, because I can't imagine any way this powers up without the power being on, I'm confident enough to say that's supposed to be normally closed contact and it's burnt out or something, and quite possibly like acts as a circuit breaker. Okay, so we get that much. So I think we have one problem there. Now then, this short that we've had. Easiest place to measure it would be across these capacitors, but I need to get this circuit board out to do that. Can we measure this across the bridge rectifier, because we can get to this? So we have here a bridge rectifier. We can see that two of the wires, these two red ones, come from the transformer. The yellow one, this will be the ground. That, yeah, it goes to like a ground terminal down in here. Let's see if we can just get to it. That one, and this will probably connect to the actual chassis, I would have thought. No, it doesn't. That's interesting. I would have thought that would go to there. And then there's some thin wires coming from here. This will be a lower voltage supply, probably plus or minus 15 on this one. Yeah, I can see they go there. So I'm expecting this to be the plus and minus 15, and this to be a much higher voltage. And I'm thinking, no, this is not a class G amplifier, it's a class AB, because it only has the one supply rail. We should then have a connection resistance from here to either of these two red wires. So this is the transformer secondary. Yeah, 1.2 ohms. So on the other one coming in about the same, I'm guessing. Got a good connection on it. Yeah, probably is the same. Just a bit of a dodgy connection. So coming out of the bridge rectifier, the plus and minus, which are these red and black, they should read, if there isn't a short, effectively open circuits. We probably charge the capacitors first, but let's have a look. So let's go on to continuity. Right, go to the red one. I know I've got a contact on here now, so we'll go into the these is the output from the bridge rectifier. That could be the capacitor charging. So let's go to ohms range. It's reading high now, so there isn't a short directly on the output of here. Okay, the short's somewhere else. I suspect then the short is probably on the amplifiers, the output transistors. So There'll be another set of these under here, but let's have a quick look on the ones we can get at first. This one will be base collector emitter, base collector emitter. The emitters will go to the emitter resistors, which are here, and then to the speaker out. Is there another set of transistors underneath? Not sure there is actually. How many is there here? 1, 2, 3, 4, 5, 6. Right. We might have here effectively PNP and NPN. If that's the case, then if I go from the positive out of the bridge rectifier, it should go to the collectors on some of these. No. Resistance is climbing up. Look on the other one. Collector. Right, it goes to the collectors on here. Does it not go to these? It goes to these as well. Looks like in fact there are more transistors under here. I think I'm going to have to take these amplifier modules out so I can check them out. Probably the easiest way. I've got the amplifier modules out. We're easy on this one. This is this relay, so it's a 24 volt relay. I'm convinced now this is normally closed and it must be faulty, the terminals. These are probably thermistors, inrush components, and they look damaged. Let me have a look. I think they might be. Yeah, definitely. So those have gone. You can see there, thermistors. So they're not VDRs, they're thermistors to stop inrush current. Those have blown, so we can add them to the list. We'll have to get the circuit board to get to this, but I'm fairly convinced that's faulty. There are some fuses on here. I might as well check them anyway. So there's two there. Yeah, it looks like there were just the two. They look okay, visibly. And they read okay. So these are the amplifiers. I've marked them left top and right top so I know which one came from where. They're probably symmetrical. You probably could put them in either way, but anyway, that's how they came out, so that's how they're going to go back in. Yeah, looks like effectively this could go the other way up on the other side and so on, but I'll put them back in the correct way. There's a green cross on here. Somebody's marked this. This is like an X. I've also noticed that this is all loose, whereas this one isn't. So it looks like somebody's already decided this one is faulty. Let's have a look. Yeah. Whether this is blown because this was loose, I don't know, but seems both sides were loose anyway. Okay. Let's see if we can see some shorts. In fact, actually, it looks like if I just loosen these, this board will just come off, make it even easier to see what we have. So we just loosen these a bit. Okay. This wire looks like it will hold it on. This is going to like a temperature sensor here. Okay. Yeah, out it comes. So A1492 and the other side will be C something. Yeah, so these are complementary MPNs, PMPs. Right, what have we got? So collector emitter. Short. These all read short. But because the emitters are all connected together via these resistors, and by the way, some of these have been changed at some point. Yeah, looks like those two have been replaced. Because the emitters are all connected together and the collectors are all connected to the voltage rail, you can't really say which is the short one by doing that. Let's look on the other side. So these, again, read short. But again, they will all read short. These are 0.5 ohm resistors. So to figure out which ones are actually short, there's two ways you can possibly go at this. One is to measure from the base. Okay, so this one, base collector reads, oh, it reads like a diode actually. That reads okay. No point going to the emitter because the emitter collector is short. That one reads short. That one reads short. That one reads short. That reads short. It may be that this one actually has an open circuit base resistor. Let's have a look. Because the base resistors are all effectively in parallel. You see, I'm reading from one to the other end of the other ones. Yeah. So I'll probably have to just unsolder all these. We could use the micro ohm or milliohm meter to see if we can find out the shorted one. In fact, why not? Let's do it. These ones, that reads short, short, short. These all read short as well. Okay. And this also makes it quite likely that some other transistors further back are blown on that one. Let's look at this one. So we know what's on here now. How's this one read? That reads okay, yeah. And this doesn't read short. So we'll see a base. We've got the positive lead on the base, so this is NPN. Okay, that reads good. Yeah, that reads good. That also reads good. Yeah. That reads good. Other side. So these will probably have the black on the base, PNP. Yeah. Reads good. No short. I only need to read a short on one, as I say, because they're all in parallel. If we don't see a short on one, there isn't a short on any of the other ones. Okay. So this is a good amplifier module. Right. There's no point me measuring around these driver transistors, these two and this one, at the moment because of the short on the output. I won't get any sensible readings. So let's just try the milliohm meter, which is probably going to tell us these are all short. So I'll go on to the 200 milliohm range first. Just zero the meter. I don't think this is actually going to help us. I think the short's going to be everywhere. Let's have a look. So we go collector emitter. That's reading 51, 50. That reads higher. Oh, that's interesting. I go up onto the 2 ohm range. So this reads, yeah, about 70 milliohms. Probably want zeroing on this range. No, it's fairly close. That reads about an ohm. About 1 ohm. Same. 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 Other side. Let's have a look. So was this one short? That 1 ohm. That one. Okay. So this one reads bad. About 1 ohm. About 1 ohm. About 1 ohm. About 1 ohm. And on this one read bad. Yeah, that one. So the milliohm meter is telling us where the problem is. That doesn't mean I would trust all of those other transistors, by the way. If they were cheap enough, I'd just replace all of them. Right, let's remove these two transistors that show bad on the micro ohm meter and see whether those are the only ones that are actually short, although I would tend to replace all of these anyway. I will just add, by the way, I don't have these transistors in stock. I need to buy a load of them, so this won't get repaired today. It'll get diagnosed and we'll go into the other parts of the circuit to see if we can find anything else that we need to order. So if you want to see this fixed, it'll be on another video, but today we will complete the diagnosis and come up with a cost for repair. Okay, so here are the two that read short. I'm sure they are short. I want ohms range with continuity. Yeah, this is short, and it's short to the base. So that means that the high voltage has possibly gone up into the previous stages through the base. Same with this one. So that does tell me I need to check transistors further back. How do the ones in the circuit look now? This is the base. Well, there's no short there. No short on that one. Let's go into diode mode. Looks okay. This is an NPN transistor. I've got the red lead to the base. So I'll put the red lead to the collector. So I'm reading something there. I'd expect that to read kind of like open. Let's look on the good amplifier. Let's just check that on this one. Yeah. So look, on the good one, I read the base emitter base collector, but this reads open. That's what I'd expect it to read because that's the normal polarities. That tells me there's something else wrong. I need to find out why we have that reading. Okay. This one, I know it does read okay, I wasn't on it properly. Again, we see that reading. Let's go down the other side. So these are the PMP ones. I'll put the black to the base. Reads okay. Now in this case, if I put the negative onto the collector because it's a PMP, I'd expect it to read open. And it does read open, okay? No, I have a bit of a funny reading. Again, let's compare that with the good one. Okay, so these are PMP, so black to the base. Junction, junction, and black to the collector. Okay, that reads about the same on this channel. Okay, that reads open that way. There it goes open. I'm less suspicious of that than I am of the other one. I definitely have a problem on that side. I can see that anyway. Just check the other ones. Yeah. That possibly suspicious, but I'm not so sure. When you're doing this collector emitter thing, you have to think of the polarity that it would normally be in and look in that polarity. I'll show you on paper in a minute. Okay, so they all look sort of okay. When you're measuring transistors and circuit, you can quite often see the junction between the base emitter and base collector, but you'll often see a diode junction in one direction or the other between the collector and the emitter, and you might think to yourself, well, is that okay? You can't exactly definitively say, but you can get a good idea. So in the case of this amplifier, the output stage looks something like this. NPN transistor. PNP transistor. There's actually some low value resistors in here, but they're very small, maybe 0.2 of an ohm or something like that. So that won't actually affect the readings you get, but they are there. And then we have out. And your speaker basically connects between here and ground. Okay, and this is your plus supply, which on ours is going to be quite high, maybe 90 volts, something like that. And this is your minus supply. Okay, so we can see on this transistor, when we put the red lead on here, I can see a diode junction that way and that way. And I know it's NPN because of that. I always think of P like plus and the red being like the positive wire, the plus. So if my red meter lead is on here and I see a junction, I go NPN, the red being the positive wire, okay? This one's a PNP, so it's the other way round. So here, I put the black meter lead on here in diode mode, and I can see junctions these ways, okay? Diode junctions with the black lead. So again, it's PNP. If you think like the black wire is negative, that's the N, and the red is positive, that's the P. That's the way I remember it anyway, the way I think of it. So I know it's an NPN and a PNP. Now, I know that on an NPN transistor, for it to work, the collector has to be positive with respect to the emitter. And on a PNP transistor, the emitter has to be positive with respect to the collector for it to work. So when I measure between the collector and emitter, if I put my red lead on here, which is the positive, that's the normal polarity of use. And the transistor, when it's switched off, should not conduct. So I should not see a diode junction or any other strange reading in diode mode in that direction. In the opposite direction I may see, but bear in mind that the opposite polarity never occurs in the actual operation of the circuit, only this one. So I'm looking with, as I showed you, red to collector. This is Y. And then on the PNP, This is the negative rail, so the collector is now negative with respect to the emitter. So I'm looking to make sure I don't have a diode junction between here and here with the collector on the black. Again, because the black is the negative lead coming out of my multimeter, and that is the normal direction of operation. So we shouldn't see, when the transistor is switched off, we shouldn't see anything from here to here. No matter what's connected elsewhere, there shouldn't be a current path red to black here or black to red there, okay? That's why. But if you put the meter leads the other way around, although you might see a diode junction, remember that that condition would never occur in the normal operation of the circuit. This is a very useful one. In fact, it's something you need to learn if you're going to be working on the electronics. You need to understand this, because otherwise you won't make a lot of sense of what you're seeing in diode mode. So if you've had that problem before, and I'm sure you have, because I used to have that problem, now I think you have a good idea of how you need to think about this. Okay, so let's go back to our amplifier. Because I'm going to be probing around this a lot, I'm just going to unsolder this thermistor. It's effectively stuck on here with some sort of like heat conducting ceramic or something, so I'm going to just unsolder these two wires. This is a thermistor, a temperature sensitive resistor. It doesn't have a polarity, so it doesn't matter which way around it was. So I'll just take these off. Okay. There. It's easier to work on now. If I didn't do that, what has probably happened while I'm working on here, these will become fatigued and fall off anyway. So let's do it, yeah. I've also noticed a couple of these have just come out from here. These will go behind some of these transistors. Yeah, this one's metal, so here, and probably that one. I mean, these are like plastic, so probably only one was needed, but that's where they've come from. I can always check on the other amplifier to be sure, but I need to make sure these go back on, okay? So that's why I'm a little bit suspicious of these. These are the NPN transistors. If I put the positive to the collector and I read to the emitter, I read this 1.79. I don't see that on the other amplifier channel. And on these ones, I have to put the black to the collector because these are PNP. And I see this 1.96. Now, on the supposedly good channel, I don't know if it is actually good, on the NPN, I also see like 1.69, okay, and on the PNP, they actually read open, so this may actually have a problem as well. I expect them probably to read open in both, in that polarity. So let's carry on a bit further with this. The next transistors I see are these two. These are probably the drivers for these. So effectively, the output from these drives the base of all these. Okay, one for one side and one for the other side. Well, it may be that this and this are the driver actually. I can't really see the markings on them. And then there's like one that sets in between these that effectively like balances it. It kind of like sets the output to 0 when the input is 0. And that might be that one. Thinking this probably drives these and this probably drives these. Let's have a look at these transistors. So diode mode, what we've got. Well, that reads like a junction, and that reads like a junction, and this is NPN, positive to the base, yeah? So from the base positive, you'd expect that to read open. I get this bit of a reading. Okay. With a negative to do here, I wouldn't be surprised to see a diode or something. I mean, I don't, but it's irrelevant because it never actually works in that polarity in circuit in the application. What's this one? Well, this kind of reads funny with a positive to the base, assuming that is the base. This is a different package. Let's have a look with a negative to the base. This also reads, that reads like a diode junction. Ah, okay. This reads diode junction here and here. This is probably the base. And then that reads that funny reading again. If this is the collector, I'd have to take the little thing off to see what that actually is. It's stuck to it. If these are the drivers and this one is MPN, I'd expect this one to be PMP. So black to the base. Reads a junction. Reads a junction. And then with the negative to the collector, I'd expect it to read pretty much open. And it reads this funny bit of a reading. So there's nothing obvious to say these are faulty. They look like they're okay. I'll check the other power transistors and just see if I can see anything else, anything obvious. These I can read the marking. So this is C, that's an NPN transistor, and the ones that start with A are PNP. I think we'll find. Let's have a look if we see a marking on this one. Well, that's the back of it actually, so we're not going to see it on that side. That's effectively same as those two, effectively the same. This looks like a PMP. And another one here. K. That might be a MOSFET actually. Let's have a quick look at them. So if this is NPN, and pretty much in these packages that is always the base. So I'll put the meter where you can see it. Okay. Base. Collector. Emitter. Positive to the collector. We see this bit of a funny reading that I've been suspicious of for quite some time. There's another one here the same. Just get to it this way. Base. Collector diode junction emitter. Yep. Diode junction and positive to the collector. That just reads open, okay. And then there's another one. This is the one that I think is a PMP. So black to the base. Junction, junction, negative to the collector. Reads a bit of a funny reading. Okay. And then this one I think is a MOSFET. Because it starts with a K. So that reads like open. That kind of reads like open. Let's go this way. This thing just seems... This one has some funny readings, so this one I'm going to have to take it out of circuit to test it. Okay, so this one that says K215. This is probably like a 2SK, and it's probably a MOSFET with that part number. Of course, we can always look that up with a data sheet, but let's see. So, component analyzer, what are you going to tell me? It's a MOSFET. Okay, that's fine. So, I'll put that back in. I have noticed actually that on this amplifier, for example, this device has obviously been changed. Those all basically have a matching logo, and the one that's faulty now is also one of those. And on the other side, I think they all look like the same logo, but this one looks slightly different, and that has a Y on it, and these don't have. So I suspect that's already been changed as well. and again the one that's faulty is one of this type. Because we've had a short circuit in the output stage, we should check these resistors around each of the transistors. So you can see each one has a 100 ohm, it has a 4.7 ohm, again 100, 4.7, and then these resistors will be a low value, 0.47 on these, okay? So now I've removed the short, let's just check all these resistors. So 0.47, well, actually that one might be open. Let's go again, maybe I had a bad connection. No, that's reading like about an ohm. I mean, my multimeter isn't very accurate on low resistances, but they all read about the same, so these I think are okay. Okay. Yeah, I've got connection on it now. That one. That one and the same on the other side. One's here. Yeah. If one of these is to fail, it's going to go open circuit. It's not going to read just a bit high. Yeah, there we go, okay. And then these ones. So this is the 100 ohm. Well, that reads 17.6. Just one. 17.5. A resistor can read lower than it is and be okay. I can just check on the other module. Actually, let's just check one of the ones on here to see if that's with the same resistor. Yeah, 17.6, so that looks the same. So they look okay. Yeah. Yeah, these all look okay. And the one that was short reads okay. And then the other one's the 4.7. Close enough. Close enough. Yeah. Yep. This one's not soldered properly. Oh, that's interesting. Can you see, there's the resistor, look. I haven't been working anywhere around here, so this is from a previous repair or job and they haven't soldered the resistor in properly. That may have something to do with why it's blown up. That's bad workmanship. And it ain't me. Okay. I wonder if somebody's tried to repair it, it's just blown up again. And then they sent it to me. Yeah. That's not good either. I think the track's gone. So this is under the resistor. And this is, no, the track's okay. It's okay. Yeah, I have a good contact there. Still not totally happy with that. I think let's have a look. Yeah, I think I'll see if I can get a bit of wire to bend over to here. Actually, I'm not totally happy with that. Right, I'm happier with that. Yeah, that's fine. Okay, so I can't find anything obvious wrong with this. I do have another problem on this amplifier that I think I have, which is around that relay, which I think should be normally closed and is reading normally open. So we need to have a look at that now to see what the problem is there. If I can get the amplifier to power up, I can probably test this. In fact, I could test this with just the transistors that are fitted to see whether it at least doesn't go bang. That's the main thing. I could feed a bit of a signal in and just see if it does actually amplify, and then it's a matter of ordering the transistors. But first of all, we need to have a look at that other PCB with the relay on. Okay, so this is the relay. I also have some faulty NTCs here, thermistors. So I'm going to have to get this board out and then we can check this. If I didn't have faulty thermistors, I'd be tempted just to power this up and see whether effectively, if I put my light bulb on, if I see it draw any power, so the capacitors charge up, then I know for definite that this is actually working. But because of these as well, I'm not inclined to do that. I think I'll get this board out and then we can see what we have here. Okay, this took a bit of getting out. I've got the board out now. I can see once I've taken the board out that these are relay contacts, but it's not like a contact from there to there. If you look, it has some more pins down here which go to these NTCs. So if we look from one end of here, that connects to there, and then from the other end of here connects to there, and this is where the NTCs are, here to here, and this reads open. So how this should work is the NTCs pass current through, they act as a low resistance, they power the thing up, and then once it's powered up it switches this relay on to short them out. That's what it's actually doing. So these are shorted out after the initial surge of current. These are obviously blown, so I need to order these and change these as well. Let's desolder them and then see if we can figure out what these things actually are. Okay, so we can see them now. NTC 5D-15. They've definitely gone. I mean, you can see what's happened to them. I'm not sure. Yes, that is a 5D. I was thinking it's a 50, but 5D15. So I need to find some of these. The relay looks okay. I was a bit concerned about that because it was a bit of a strange thing, but I'm sure that is okay. I can understand how it works now. So I'm ready really to give a quotation on the guy. I'm gonna price up for replacing all the transistors on the faulty channel. I'm fairly confident the one is okay, but it's just fairly confident. If I do that, then if I need some other parts, I've kind of covered for it. I can see that the previous repairer has only changed 2 transistors, and I can also see that they've botched it as well. There was a resistor there that wasn't connected basically, or was barely connected. I'm suspicious that might have caused a second failure. So if it was happy with the previous repairer, then I'm happy enough to change the pair of transistors that are definitely faulty. I'll see what he wants to do. I can give him a price either way. If I add a little bit onto the cost of parts, then if it turns out I need a few other bits, it's not really a problem. But I don't see any obvious reason to suspect that the short has effectively gone back into the previous stages, because the driver transistors check okay, they look okay. I'll have a look to see if I can find the price of the transistors and if I can find the price of these NTC thermistors. Then let's see how much I'm going to quote this guy. Okay, so there are quite a few sellers of these on AliExpress. I've found several of them that have good reviews, including this one. A lot of them seem to be sold in pairs like these. So this one has 5 stars. There's a few reviews. The reviews are good, so that's probably what I'm going to buy. You can get 5 pairs for, well, adding the postage onto that is about €8 or something, minus the VAT, which I don't pay. So that's 21% off. There are 6 pairs on each amplifier, so that's 12 pairs. If I get 15 pairs, I've got a few spare ones, it's going to cost me about €24, so that's fine. And if I don't use them all, I've got some useful parts, and if it does turn out I need a few more transistors, they're going to be cheaper than these, and there won't be so many. So we'll do that, we'll go with those. Now let's have a look at these NTCs. Yeah, there's a seller here that has the whole range of different ones. So 5D15 is on here. Yeah, that one there. So that's like €1 for effectively 10 pieces. I might actually order a few more of these. I might order a bit of a range of them while I'm at it, and then I'll keep them in stock. But that's cheap. I mean, it's practically for free, really. And that's with €1.88 of shipping, so still less than €3. They're not expensive, so that's that one as well. Okay, so I've ordered those parts. I need those anyway, but I'm not convinced that there is no other fault on this amplifier, at least on that channel, and maybe on the other one. I'm still not happy with these readings I'm seeing on the collector emitter and the effectively polarity that the thing is powered up in. So while I'm waiting for the parts, I'm going to have another look at this amplifier. This video is long even by my standards, so we'll do a separate one. What I want to do is actually power this up and see whether it does that and doesn't draw much current. I mean, without a signal in, it should literally be like in a quiescent state. Once the capacitor's charged, the current draw should be very low. I can do that. If I put my light bulb in series with this, then I can effectively short out those thermistors. It won't be a problem. There won't be a high inrush current because the light bulb's there. The light bulb will also limit the current it can draw anyway if something bad happens. The fact a couple of the output transistors are missing is not relevant. I'm not going to try and drive the amplifier. I just want to see that it balances with effectively 0 volts going out to the speaker. I'll probably connect something like a 10 ohm resistor instead of a speaker while I do this, just give it some connection from the output of the amplifier to ground. There's a few different ways I could do this. One way in particular is to use my variac. That's the thing that sits here. This allows me to vary the mains voltage from effectively 0 volts AC up to 240 volts plus 10%. Actually, I can go 10% boost as well, and it's variable on the control here. So if I use that with the light bulb in series, I can start off, if I like, with a low voltage supply coming into the amplifier, and the light bulb will tell me if it's drawing a lot of current. The other option is to use my bench power supply, which is here. So this is a dual supply. It goes up to plus and minus 30 volts. Now I know the amplifier runs on a much higher voltage than that, but if I take the amplifier module on the desk, connect that power supply, again a 10 ohm resistor or 20 ohm maybe, just to limit any current going back to the ground from the speaker output, I can effectively just put some voltage onto the amplifier just with the module on the bench and see how it reacts to that. I think either of those will show up a fault if there is a fault condition there, and I may even with a thermal camera be able to see where the current is flowing. So that's what I think I'll do. But you know, you might have a better idea. So let me know in the comments below. And how would you proceed with this? Or would you just wait for the parts to arrive and then put it back together? Okay, hope you enjoyed that. Look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.